The title's supposed to be clever, but it's kind of sad. In 1991, one of my textbooks had a great little map. It shows where eclipses are going to be anytime for 50 years. And looking at that, I thought, wow, there's going to be an eclipse right in Hawaii. And so I went to Great Lakes and did a lot of planning, and I went to Hawaii to see the eclipse in 91. Did my research. I went to the same place where all the astronomers and all the photographers went. It was supposed to be 96% chance clear skies. And that morning it was beautiful, sunny and blue skies. And as the moon started to cover the sun, the clouds started to grow. And by totality, we were standing in clouds. Can you imagine 8,000 astronomers with millions and millions of dollars worth of telescopes and cameras? It was just like, just all the air went out. And then the sun came out and the clouds went away and we packed up and went home. And then in 2009, my wife Janet and I were both teachers. We saved our nickels and dimes and went to China to see the total eclipse. And that was even more of a washout, where we went to with a tour group, and it was overcast, and it was raining, and it was storming, and everybody was set up. We went to this resort hotel and we waited all morning and hoping the sky would clear, but it never did. And at 10:30 in the morning, it got dark and the parking lot lights came on. It was pretty neat, but I still haven't seen a total eclipse. So I've been to 2, but I'm 0 for 2. And so my friends say, Dean, where are you going to go for the eclipse? And I say, well, yeah, because they don't want to go there. They say, you're bad luck. You tell me where you're going, we'll go somewhere else. So hopefully, 4 days from now, I won't be saying I'm 0 for 3. Okay. I want to start with just talking about what's going to happen. We all know the Earth is orbiting the sun. And we all know that orbiting the Earth is the moon. And every once in a while, everything just lines up. We're going to talk about that quite a bit later, so that the moon exactly covers the sun. Now, wait a minute. The sun is pretty dang big. It's over 800,000 miles across, 100 times the diameter of the Earth. And the moon is pretty small. It's less than 250,000 miles, a fourth the diameter of the Earth. So how does it work that in the sky they're the same size? Well, here's an activity anybody can do. A lot of what I'm doing is for teachers, especially middle school and younger. Let's say this is the sun. Now, everybody here, participate. Don't do like high school students that are too cool to participate. Put your thumb out in front of your face, and you should be able to move your thumb either closer or further to where your thumb exactly covers the sun. At some distance, they should be the same size. Has everybody got it? Well, that's exactly what happens in space. The moon is anyway, the ratio of the distance to the moon and the distance to the sun is the same as the ratio of the size of the moon and the size of the sun. That's just that amazing coincidence. One of the professors at Fort Hays I did a program with did some research. He said they think nowhere else in our entire solar system is the moon in the sky big enough to block the sun. Well, no, way out there. But yeah, that's true. Yeah. So our moon is almost exactly the same size in the sky as our sun. That is way cool. Okay. And so what's going to happen Monday as your thumb is the moon? Here's the sun. Just have your thumb move across, and then it's going to block the sun, and it's going to keep moving, and then the sun will come back out. That's a solar eclipse. Okay? Okay. So, somebody keep doing this. I can talk for hours. So, okay. Been there, still haven't done that. Which way must? Oh, I'm pointing the wrong way. There we go. There we go. So, during totality, and how many of you are planning to go to be in path of totality? Okay, you've been planning and thinking for a long time, haven't you? Okay, and are you checking the weather reports? Nebraska isn't looking so good. So for years, people have been saying for months, where are you going to go, Dean? And I say, well, we're planning to go up around Kearney or Grand Island, but we're leaving our options open. We didn't get a motel room. We haven't gotten a campsite, because if it's going to be cloudy, we're going to drive. If we have to go to Casper, Wyoming, that's where we're going to be, because I want to see this one. Okay, you have to leave your options open. Okay, but if it happens, just look at that. That's a photograph of a solar eclipse. That is the disk of the moon almost exactly covering the disk of the sun. So that's what we're hoping to see. Okay, we'll talk about that again later. Okay, in 1604, or just after 1600, Johann Kepler published his Laws of Planetary Motion. Spent the latter part of his life writing mathematical equations that can exactly predict the positions of objects in space. And so that means for over 400 years, we've been able to predict eclipses. Well, the ancients knew how to do it, but they just did it by keeping track and keeping records. And using Johann Kepler's Laws of Planetary Motion, you can find maps like this. That's the one I showed you from my old textbook. Shows anywhere in those stripes is where there's going to be a total solar eclipse. You have to be in the path of the eclipse because where that blue stripe is, that's the only place where the moon will completely cover the sun. Okay? And if you notice, here we are. This is our eclipse. Whoops, not supposed to do that. Here's our eclipse this next week. And then if you look again, lucky, in just 7 years. Those of you may plan your retirement or plan your vacation. In 7 years, there's another one, where is it? 2024, April 8th. Another one right across the United States. Okay. Janet's kind of excited. There's one in Australia. It doesn't show on this map, but there's going to be one across Australia, I think in the early 20s or something. People plan their vacation time. There are people who plan their vacations around solar eclipses. Okay. Okay, I like to call this Carly Simon's eclipse. Remember that song, You're So Vain? People, what is she singing about? You flew your Learjet up to Nova Scotia to see the total eclipse of the sun. Whoever she's singing about, he was rich, he could afford it. He got in his Learjet and he flew to Nova Scotia. No, the other way. To be in the path of the sun. Okay, I'll get this figured out eventually. Okay, so that was the last total one. No, in 78 there was one. And in 78 there was one that came across Canada and just up into Montana, way up north. It didn't end it. Okay, and then a lot of people say, I remember one when I was in junior high. I remember one back in the 90s. Well, that's probably this one. Now remember, the orbit of the Earth, the orbit of the moon as it goes around the Earth, it's not a circle. That's Johann Kepler's first law. Okay, orbits are elliptical. So if you think of this is the moon and this is the Earth, sometimes the moon is farther away and sometimes the moon is closer. Well, when is the moon going to be smallest in the sky? When it's further away. And so if an eclipse occurs when the moon is at apogee, farthest away from the sun, the moon in the sky is not big enough to block the sun. And so you still have sunlight around the edge of the moon. That is called an annular eclipse, and you would see something like this. You see, the disk of the moon is not big enough to completely block out the sun, and that was the eclipse in 94. The sky doesn't get dark, the stars don't come out, because there'll always be a ring of bright sunlight around the disk of the moon. And it just has to do with the geometry. If the moon is farther from the Earth, it takes up less space in the sky. Well, there's also the geometry. The Earth's orbit is not perfectly round, so sometimes the Earth is closer to the sun, so the sun would be bigger, or sometimes the Earth is farther from the sun. So you got those three geometries going to make this all work. Okay, this is the one we're going to see. Anywhere in the red shading, the sun will be at least partly blocked by the sun. And anywhere in the brighter red, that's where it'll be 90% blocked. But if you want to get behind the moon where you can't see the sun, it has to be in that dark path. And there's all kinds of maps. It's clear last March I was saying there's going to be tons of information. This is going to be in the TV, and it's going to be in the magazines, it's going to be in the newspapers. I just went to the magazine rack at Dillon's. There's tons of stuff. Well, this was a month ago, and by now they're all gone. Okay, this is the big eclipse of this year. And notice, all of Kansas, even clear down in Liberal, they're 90%. All of the United States, continental United States, is going to see at least 70% of the sun blocked by the moon. Okay, pretty amazing. But if you want to see totality, if you want to be in the shadow where the stars go, the moon is completely blocking the sun, you have to be in that narrow red stripe. Okay? Okay, just quickly, there's a whole industry. There are companies This is called Ring of Fire Expedition. That's who we went with to China. And there's an entire industry around taking people to solar eclipses. When we were in China, there was like 70 of us, 2 bus loads, and they do all the arrangements, plane tickets and hotel tickets and bus arrangements, and they take you to touristy things. They make it interesting because the eclipse just lasts a few minutes. But it's a really neat way to travel because you're going to go places you would never, ever otherwise go. We were talking to people who had ridden camels across the Libyan desert to get into Path of Totality. We talked to people who got in jeeps and went across the bogs and swamps of Siberia to get in totality. And so if you follow eclipses, you're going to go places, not just the touristy places everybody goes, you're going to end up in places that you would never otherwise go. So something to think about. 2024, that's when you're just going to be able to drive to. But if you get caught up in eclipse fever, some people just, once they've seen one, they just want to see them again. There's all kinds of companies, and 3-day trips for a little money or 14-day trips for a lot of money. Okay, so this is just a poster from the one in China. That's where it was. Notice it went right across India, right across China, the 2 most populated nations on Earth. Probably a third of the people in the world were within a day's drive of this eclipse. And yet when we got there, the hotel staff didn't even know it was happening. They didn't know why all these people were out here with cameras. Isn't that amazing? Okay. And so we flew into Shanghai. Sometime get me to tell you my story of Shanghai and the shoes. But it's just traveling, all the great things that happen when you travel. And eclipse day, we flew to Wuhan because it's out in the central area. It's supposed to be clear, but it wasn't. And so when they always, if you take one of these tours, they put it together, you see the touristy things. We got to see the awesome skyline of Shanghai, and we got to see the terracotta soldiers, and we got to go on the boat ride in the little villages like Venice. The villages are all, and we went to this bazaar where they were selling spices and food and crafts, and this lady had this bubbling cauldron. It smelled so good. She said, "Would you like soup? Would you like soup?" And I said, "What is that?" "That's goat hoof soup." And I said, "Well, we just have breakfast, no thanks." But if you go on one of these tours, they really make it so you experience the culture, the geography, the history. It's a really good way to travel, but I'm not making any money. Okay, but also if you go on one of these tours, they bring in experts. The lady in charge of our tour was an astronomy professor at Rice University. Interesting. She was really neat to be around. But this guy, astronaut Claude Nicollier, he was the mission specialist who went on a spacewalk to install the corrective optics for the Hubble telescope. Remember when they put Hubble in space, it was out of focus? And so the engineers were frantic for 2-3 years. They figured to fix. Well, he was the one that took the lens to put in the optical path to fix the optics so the Hubble could see. So anytime there was an empty seat by him at dinner or on the bus, you want to, interesting people, you want to get around them and talk to them and learn things. So here we are. This is the hotel where we were set up. You can see people setting up their cameras and their telescopes, and they all got umbrellas and they got plastic bags. It was raining. It was cloudy. It was a gloomy day. And we're all just hoping those clouds are going to part and give us a glimpse. But, oh, there's a cute young gal looking through one of my solar filters. Oh, I forgot to say, my wife Janet's here. She's my technical support. I couldn't do these PowerPoints without her troubleshooting and helping me out. So thank you, Janet. And that's what the sky looked like. And we were hoping it would part. But it got dark. And the street lights came on, the parking lot lights came on, and all these people that brought all this equipment just it was dark. And then the sky started getting light, and the sun came out. Didn't the sun come out, but it got light, and people just packed up their stuff, and it was over. So hopefully that's not going to happen to us. Hawaii, I didn't have a digital camera. Somewhere in some box in some closet is a bunch of slides, but this is just most of the people that did it right went to the place that was supposed to be clear, got clouded out. And on the other side of the island, where it was supposed to be rainy and cloudy, the sun came out and they watched the eclipse. It's just one of those things, okay? And when you go to these eclipses, people have their telescopes set up. There's people, it's just, there's going to be thousands and thousands, millions of people traveling to this eclipse on Monday. You can even get on cruise ships. There are cruise ships that plan cruises. Can you imagine watching the eclipse from the deck of a cruise ship? That'd be a pretty neat way to go, okay? So if you're interested, after Monday, if you really like it, start planning, save your money. Okay, this is what we're hoping to see. The moon is blocking the sun, and when that is true, we can see the corona. This is the hot gases that surround the sun. They're lit up by the radiation from the sun. And normally when the sun's out, you don't see those because you're way overexposed, overpowered by the bright light coming from the photosphere of the sun. But when the moon blocks the surface of the sun, you can see this corona. Okay? And what are these bright specks? Remember, the surface of the moon is not, it's not like a billiard ball. It's got mountains, it's got hills, it's got craters, it's got valleys. And so around the edge, this might be a little beam of light poking through some little gap in a mountain range. Okay? You see these bright, they're called Bailey's beads, because some guy Bailey said, I'm going to call these Bailey's beads. And everybody said, okay, we'll call it that. Okay? So here's how it works. Anytime the sun and the moon exactly line up, you have a chance for an eclipse. And it's my favorite, one of my favorite words, syzygy. It's an old word. It means anytime three bodies are in an exact line. Can you imagine using that in Scrabble? But I think there's only two Y's in Scrabble, so you might have to have a blank. If you got your Z in the right place, that could be worth a lot of points. But syzygy is anytime any three bodies are in an exact line, so all eclipses, lunar or solar, occur at syzygy. Okay, and here's some terminology. The darkest shadow. Oh, so why does the shadow come to a point? Think about it. The sun is 400 times bigger than the moon in diameter. And so even though it's way, way out there, the sunlight coming past the Earth, past the moon, is going to come to a point. Okay? And so that inner shadow where the moon completely blocks the sun is called the umbra. Shadow, umbra, umbrella, I think they're related. And the partial shadow, if you're anywhere out in this part, that's where just part of the sun is covered. That's called the penumbra. And you here in Hutchinson will be in the penumbra. And those of us driving to Nebraska hope to be in the umbra. We'll be in the umbra. We hope it'll be clear. Okay? Okay. I've been seeing these for weeks. They're on TV now all the time. But what's wrong with these diagrams? Somebody say scale. Not the scale. First of all, if the moon's that big, the sun would have to be bigger than this entire building. Okay? And obviously the distance is all wrong. So I put together a model. I made one. You got to have 4 to 1. The Earth is 4 times the diameter of the moon. So I went to Hobby Lobby and bought me a little, this is a 4-inch ball and a 1-inch ball. But then I thought, why not find something that every elementary teacher can get, has in the closet, a softball. If you have a softball, and I did the math, it's very close. It's like a 2% difference. If you have a softball and a quarter, that's almost exactly 2 to 1. So if this is the size of the Earth, this would be the size of the moon. But for visual effect, I just found a little 1-inch styrofoam ball. So let's get the scale right. If this is the size of the Earth, thank you. That's fine, whatever you want to do. Then this would be the moon, and they would be this far apart. Now, can you start to see why there's not an eclipse every month? If the sun is out there, think about it. If this isn't exactly lined up, most of the time the shadow of the moon is going to go above the Earth. Or in other situations, the shadow of the moon is going to go, well, shadows don't make noise, but the shadow will be under the Earth. So it takes a very special alignment to where the center of the sun and the center of the moon and the center of the Earth are exactly lined up. And what's that called? There you go. Okay. So this is to scale. Okay. Now, does anybody know, am I facing east? Something tells me I'm facing east. Okay. Well, anyway, now let's put the scale of the sun. If the Earth was that big, the sun would be 33 feet. That's about the size of this room. And how far away would it be? Just over a mile. And so if that way's north, well, we have to do it the other way. It'd be up to the state fairgrounds. So to scale, thank you, assistant. If the Earth was this big, the moon would be this big, and the sun would be as big as this room. And this is 13.5 feet, if anybody wants to know. A softball, a quarter, and 13.5 feet. and the sun would be 33 feet in diameter. Oh, all that. I'm a numbers guy. This orange sheet, this is one I put together, and it has all those statistics right there if you want to make that model, okay, at the top of this one, okay? Especially elementary, middle school teachers would want to make that model so they can, well, why isn't there an eclipse every month? Well, that's the reason why right there. Any questions? Okay, I'm probably going to go long. Somebody needs to start doing this. Oh, I keep doing it backwards. There we go. Okay, there's Bailey's beads, the bright light poking around the edge of the moon, peeking through the craters and the valleys of the surface of the moon. Now, just think about it. The moon is black and dark, and it's blocking the sun. Just think that last instant, that last tenth of a second before the moon goes, there's going to be one little speck of sunlight, a bright intense. Can you imagine that? So in this model, if the moon is just covering the sun, which direction is the moon moving? Up or down or left or right? It's moving down. Another second, that light's going to be out, the moon will be completely covered, and that's called the diamond ring effect. You can see the glow of the light around the moon and that last little bright speck of sunlight. Somebody called it the diamond ring effect. That's a pretty cool name. Okay. Okay, so imagine this is a sequence of photographs. You take this picture, this is what you guys are going to see. Let's take a minute to talk about that. Everybody's so frantic about finding their eclipse glasses. Yes, you need to protect your eyes. But eclipses are very slow events. It's going to take 90 minutes for the moon to cover the sun. And then for 90 minutes, the moon's going to uncover the sun. You're not going to stare at the sun for 90 minutes. If you have 5 or 6 people and one eclipse glass, look at the sun, see what it looks like, and then have the next person look at the sun and see what it looks like. And then 10 minutes later, do it again. Oh, it's a little bit different. You don't need your glasses on for 90 minutes. And so people are, oh, there's 4 of us, and I only have 3 eclipse glasses. I say, good, give 2 away. Okay? So it'd be very easy and appropriate to just take a look and observe what the sun looks like and then pass it to somebody else. Okay? Okay. Let's finish this. Okay, so let's say each one's 10 minutes further. And then this is probably about what you're going to see here in Hutchinson. Maybe even a little thinner than that. That's about all you're going to get. And then the moon is going to move away. It won't never totally cover the sun. What do you call this one? Diamond ring effect. And then this is totality. It's total. The sun is completely blocked. You can take off your glasses. You can look at the corona. You can hope to see Bailey's beads. The stars are out. Okay, that's for 2 minutes and 20 seconds, 2 minutes, 30 seconds. Up in Nebraska and over Missouri, the sun will be completely blocked. But then, what's this again? That's the next diamond ring as the moon is moving away, and it's time to put your glasses on because now we have the direct sunlight coming back. Make sense? Okay. And then it unfolds down below. Again, the further from the totality line, the less of the sun will be covered. Here in Hutchinson, what are you, about 94%? Okay, and that's just a time-lapse photograph, the whole sequence of events. Those are pretty cool. Okay? Okay, this is about what you'll see here in Hutchinson. That's the maximum you'll see. This moon will never completely cover the sun. Okay, it's important to talk about eye safety. I did a program with our optometrists. We did a program for every teacher at the Hayes High School, at the Hayes School District, and talked about somebody planned ahead. They were thinking ahead like astronomers do, and got eclipse glasses for every student at Hayes High. And a bunch of the elementary principals or some special ed teacher, there's a whole lot of these around. But again, if they had one for every 4 people, it'd be okay. They could look and pass them around because they're not going to be in totality. Okay. And guys, our bodies take care of ourselves. If you stare at the sun, why is that not good? It hurts. Your body says, don't do this. You close your eyes, you look away. Well, you just got to listen to your body. Okay? Now remember, there's a whole lot of stuff coming from the sun besides visible. Ultraviolet is what does the damage to your retina, your photoreceptors in the retina. And infrared can damage the cornea and the lens. Okay? So different parts can do different damage, but it can, you want to protect your eyes. It's never safe to look at a partial eclipse. Even when 99% of the sun is obscured, the remaining crescent is intense enough to cause retinal burns, can cause permanent eye damage. So be aware of that. You've all seen the pinhole cameras, and this is a clever picture from the 50s. And I made one, and it worked, and I was going to stand there with my head in the box, but I left it in the garage at home. But it's not, oh wow, people are going to be, is that all there is? Just this little image, but you let the sun go through a tiny hole, and you will see the image of whatever shape the sun is. Look at this. Somebody just held up a colander. This is the guts of our salad spinner. And if you put that up in the sun, you would see a bunch of tiny little crescents. Isn't that cool? Or just make where's that? This is a card we got at the Discovery Center in Wichita that has a little hole in it. And if you held it up and looked on the sidewalk, you'd see a little crescent or whatever shape the sun is in. So that's the whole camera obscura, the pinhole camera. Look at this. This is sunlight coming through the trees. Isn't that cool? So look down at the shade. We saw a picture, somebody did this with his fingers. Held it in the sun and looked, and you saw a bunch of little crescents, the light coming through your fingers. So there's ways to see the effect without directly looking at it. Okay, that's just. So you have to have approved glasses or a welder's helmet. So there's ways to see it. Not safe to use binoculars without special filters, and people think they're going to put their Eclipse glasses at the eyepiece of their binoculars. Very bad idea. Okay, and remember, binoculars gather more light and bring it to a point. It's going to fry right through this. If you're going to do that at all, you would put this at the objective end, but that's still not a very good idea. Okay. Okay, here's the times here in Kansas. It's probably in the newspapers. You guys don't need, but it's going to occur just before 1 o'clock. Will be as deep as the eclipse gets. Oh, sorry, what?
It starts about 11:30.
Yes. This is when it begins, so just go perpendicular. Okay, how did we say I do this? Where's Brad? What do I have to do to make this start? This is worth checking out. It's okay. Janet found this one. Got to go up, 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 up. Thank you. So this is what you'll see, and it tells you for each latitude. That's all you're going to see here in Hutchinson. Okay, it'll run through again. It's going to take an hour and a half for the moon to almost cover the sun. And then right here, that's as much as you're going to get, and then the moon is going to move away. Isn't that pretty cool? Okay. And here's the path. And, oh yeah, we can go to the next slide, Brad. How do I do that? There you go. Thank you for your help. Okay. Ta-da. Now, I think the big news of this is going to be the traffic jams. There's already traffic jams in Oregon. They're already saying they're running out of gas and food at the grocery stores in Nebraska. Folks, if people travel halfway around the world and spend thousands of dollars to Eclipse, think how many people are going to just drive 2 hours up the highway. Okay, they're thinking 135 north from Wichita might be bumper to bumper. I mean, okay, so traffic is going to be the big news. This was a sign in Hawaii: beware of parked cars and Eclipse viewers. Okay, so it's going to be crazy, and I hope you have a good chance. Next total eclipse for 2024. Thanks to Johann Kepler for his laws of planetary motion and Janet for all her help. Okay. Happy viewing. Travel safely. Take care of your eyes. If I went long, sorry. Anybody have any questions? Yes.
So at totality, are you able to use binoculars?
Yeah. Yeah. I would still be careful because when that first peaks out, you don't want to get a blast. But yes.
So how come it's safe to see the favorite beams?
Ooh, that's a very good question. That's intense light, but it's a tiny fraction of the sun's disk. So no, nobody's ever asked me that. So anybody know the answer? Why is it safe to see Bailey's beads, or are we taking a chance there? Okay, question.
Will there, even though in Hudson, even though it's 90%, won't there be a little more twilight area, even though?
Oh, yes. You should be able to notice the change in temperature, and there should be a perceptible dimming of the sky. Yeah. Yeah, yeah. Like a little bit before sunset. So, yes.
Well, I think someone has to mention that these glasses, like any glasses, are only good for 3 minutes.
Yeah, you're not supposed to.
You're not supposed to stare at
You're not going to watch for an hour and a half. I mean, who's going to stare at one thing for an hour and a half in today's attention spans? You look and you make some observations, then you do something else. Thank you for bringing that up.
It's written on them, but I want
Yeah.
people to realize that if you use them for a very long period of time,
It's still going to cause you
you're
damage.
still going to have problems with your eyes.
Okay. Thanks for letting me share. Hope you have a good experience.